To imagine traveling at the speed of light is to begin with one of the oldest fantasies in human thought, the fantasy that ultimate speed must also mean ultimate freedom. If nothing in nature moves faster than light, then surely light itself must possess the secret of perfect travel. It crosses the dark between stars. It leaves galaxies and enters others. It arrives from the early universe carrying the memory of a time before Earth existed. Light seems to do what every civilization has wanted to do since it first looked upward. It goes where distance appears powerless to stop it. That is why the idea feels so intoxicating. Say the phrase out loud and the mind immediately becomes cinematic. Planets fall behind, years collapse. The stars stop being destinations and start becoming scenery. The body is no longer slow, no longer trapped in biological patience, no longer humiliated by the arithmetic of astronomy. To travel at the speed of light sounds like the final victory over distance itself, the moment at which the universe at last becomes proportionate to desire. But here, almost at once, physics begins to turn against imagination. The speed of light is not merely the fastest speed we happen to know. It is woven into the structure of space-time in a much deeper way. It is less a highway than a limit, less a privilege available to all travelers than a boundary condition built into reality. And the cruelest part is this: the closer you move toward it, the stranger the universe becomes. Time changes, space changes, energy grows monstrous, starlight distorts, radiation hardens, dust becomes violence. Even before one reaches the final impossibility, the journey starts shedding the fantasy that made it attractive in the first place. The first truth is simple and severe. If you have mass, you cannot travel at the speed of light. Not with current technology, not with fantastical chemical engines, not with perfect rockets. Not even in principle, according to special relativity as it is presently understood. Massive objects can be accelerated closer and closer to light speed, but never all the way there. The reason is not a practical shortage of fuel alone. It is more merciless than that. The energy required to continue accelerating rises without bound as you approach the speed of light. This is one of those facts that sounds technical until it lands emotionally. The universe does not merely make ultimate speed difficult. It makes it asymptotic. Every additional gain becomes more expensive than the last. 90% of light speed is already astonishing. 99% is vastly harder. 99.9% is harder still by an almost obscene margin. The dream of simply pressing harder on the accelerator and eventually matching a photon belongs to a more innocent physics than the one we actually inhabit. So the title question already contains a paradox. What if you traveled at the speed of light? Strictly speaking, you cannot if you remain a massive human traveler. The honest version of the question must therefore become something slightly stranger. What would the universe look like as you approached the speed of light as closely as physical law allowed? And why does that approach itself reveal how misleading the fantasy really is? This is where time begins to bend. Most people first meet special relativity through the phrase time dilation. And because the phrase is familiar, they often underestimate how unsettling it really is. Time dilation does not mean that clocks are simply wrong. It means that different observers moving relative to one another do not agree on elapsed durations in the ordinary intuitive way. A fast-moving clock runs slow relative to a stationary observer's frame. If you traveled at a substantial fraction of light speed, less time would pass for you than for those who remained behind. At low speeds, this effect is tiny. At the speeds of everyday life, it is almost irrelevant except to instruments of extreme precision. But as velocity rises, the effect becomes enormous. A traveler moving near light speed could cross distances that from Earth's perspective would require decades, centuries, or more, while experiencing far less subjective time aboard the ship. This is one of the great seductions of relativity. It seems to promise that the stars may still be reachable within a lifetime, provided one is willing to pay the energetic price. And yet even here, the fantasy is less comforting than it first appears. Time does not stop for the rest of the universe merely because it passes more slowly for you. The Earth continues, Civilizations continue. History unfolds without waiting. The voyage becomes shorter only by separating you more completely from the chronology of everything that launched you. Relativity offers not a free victory over distance, but a bargain in which you cross the abyss by surrendering synchrony with home. There is a companion effect to time dilation, and it is just as strange: length contraction. From your own frame, if you are moving at relativistic speed, distances in the direction of travel become shorter. This is one of the reasons interstellar journeys can seem more manageable to the traveler than to the world left behind. It is not only that your clock runs differently, it is that the road itself contracts. This sounds almost magical at first. A star 4 light-years away does not remain 4 light-years away in quite the same way for an observer traveling fast enough. The faster you go, the more the path shortens in your frame. The universe seems to pull inward ahead of you, not because the stars are actually deciding to be kind, but because space-time gives distance and duration together rather than separately. Yet the emotional cost remains. The shortening belongs to your experience. To everyone watching from the original frame, the distance has not politely folded itself for your convenience. They still wait through the full chronology of the voyage. This is why relativistic travel is not a simple story of going fast. It is a story of entering a different relationship with reality than those who remain behind. Every gift comes attached to estrangement. At this point, the imagination often takes one reckless step further. If traveling near light speed makes time almost stop and distances collapse, then what about traveling at exactly the speed of light? Would time freeze entirely? Would the whole universe contract into nothing? Would you experience the journey to a distant galaxy as instantaneous? It is here that ordinary intuition becomes especially dangerous. Physics allows no rest frame for a photon. One cannot consistently ask what a beam of light experiences in the same way one asks what a passenger on a ship experiences. Light does not possess a normal traveler's perspective that you can borrow cleanly. The mathematics of special relativity break the naive picture before it forms completely. The speed of light is not just another speed occupied by an especially lucky object. It belongs to a different category from the speeds available to massive things. This matters because much popular imagination quietly assumes that if only humans could become light for a while, the universe would turn into pure, easy transit. But the phrase itself is already cheating. Human beings do not survive as photons. Bodies, memories, organs, chemistry, and the very structure of personhood are all bound up with mass, matter, and internal timescales. The speed of light is not waiting as a hidden travel mode for flesh. It is the speed at which massless things already move, and that difference changes everything. Still, let us continue the thought experiment honestly by staying just below that impossible threshold. Suppose you are in a vessel traveling at 99.99% of the speed of light. The engine has done something no civilization we know how to build could manage, and yet you remain a massive traveler rather than an impossible beam. What happens first is not what science fiction usually shows. The stars do not simply become fixed white streaks. The universe becomes optically strange. Light from ahead is compressed. Light from behind is stretched. The direction of incoming light shifts. The sky no longer behaves like a calm dome of points evenly distributed around you. Relativistic aberration squeezes more and more of the visible universe into a brightening region ahead of your motion. The cosmos begins to pile up in front of you like weather driven by impossible wind. This means the act of seeing itself becomes distorted by speed. The starfield ahead grows crowded, harder, more intense. The world behind fades, reddens, and thins. Travel at near light speed would therefore not feel like gliding serenely through familiar astronomy. It would feel like the universe had become directional in a violent way, as though all vision were being dragged toward a single forward wound in space. The color of the universe would change with equal brutality. Light in front of you would be blue shifted. Wavelengths would be squeezed shorter and shorter, pushing visible light upward into ultraviolet, then X-rays, then gamma rays if the speed became extreme enough. Light behind you would be redshifted and stretched downward, slipping through infrared toward radio silence. The sky would no longer be divided into stars of different temperatures and colors the way it is for slower eyes. Speed itself would begin repainting the cosmos. This has a terrible implication for any real traveler. Starlight is not only information. At high enough blue shift, it becomes hazard. Radiation that was once harmless visible light can harden into something much more dangerous. The calm-looking sky ahead would begin, in energy terms, to resemble a beam of increasing hostility. Even the cosmic microwave background, that ancient cold afterglow of the early universe, would not remain innocent forever. At sufficiently extreme speeds, it too could be shifted upward into far more energetic radiation. So the dream of rapid travel turns darker. You thought speed would merely shorten the road. Instead, it changes the road into something actively more lethal. The universe in front of you becomes not just nearer, but sharper, hotter, and more violent. The very act of moving faster weaponizes the sky. Interstellar dust then enters the story, and with it the fantasy begins to suffer real physical humiliation. Space is mostly empty, but mostly empty is not empty enough when velocities become relativistic. A tiny grain of dust encountered at ordinary spacecraft speeds may already be a concern. At near light speed, it becomes an impact of obscene energy. A speck no bigger than a grain of sand can strike with consequences more like an explosive event than a mere collision. This is one of the least intuitive and most terrifying aspects of the scenario. You do not need an asteroid to kill the ship. You do not even need a pebble. The medium between stars contains enough sparse material that at sufficient speed, every encounter becomes a potential wound. The front of the vessel would require shielding beyond anything current engineering casually dreams of. It would need to survive not one dramatic impact, but a long campaign of tiny catastrophes arriving from the forward direction at energies that make ordinary armor sound naive. The philosophical lesson returns with force. On Earth, speed is often associated with mastery. In deep space, extreme speed becomes a way of converting trivial things into mortal threats. A universe that seemed empty enough for triumph turns out to contain more than enough matter to punish hubris. The hydrogen atoms between the stars make the picture even harsher. Interstellar space is thin but not void. A ship moving at a significant fraction of light speed would plow into individual atoms and ions with tremendous energy. What is negligible at low speed becomes a stream of radiation and impact at high speed. Over time, even this diffuse medium could erode surfaces, damage electronics, and contribute to a growing burden of energetic hazard at the nose of the craft. This means that traveling near light speed is not merely a matter of finding an engine. It requires solving the physics of survival against the medium itself. Magnetic shielding, plasma shields, sacrificial material layers, field configurations, and elaborate forward defenses would all enter the picture. Yet each solution would have mass, complexity, and failure modes of its own. The ship becomes less like a sleek arrow and more like a moving fortress trying to cross a firing line too sparse to be seen and too energetic to ignore. Again, the fantasy thins. The faster you go, the less the universe resembles open room. Speed does not empty space. It reveals how much danger was hidden in what you had lazily called empty. Then there is the question of acceleration itself. Most cinematic treatments leap straight from stillness to dazzling relativistic motion, as though the body and the ship merely agree to become fast. Real acceleration is another cruelty entirely. To reach a significant fraction of light speed within a humanly manageable time, one would need either enormous sustained acceleration or astonishingly long periods of more modest acceleration. Both options wound the fantasy. High sustained acceleration crushes the body unless carefully controlled. Even tolerable acceleration sustained long enough becomes an engineering demand of frightening scale. Every second of thrust consumes energy, stresses the structure, heats systems, and deepens the problem of carrying enough reaction mass or using some other propulsion regime of equally implausible power. And if you want to arrive rather than merely rush past, you must later decelerate as well, effectively paying the cost twice. This makes the imagined trip feel less like a clean burst of speed and more like an industrial ordeal. The vessel must not only survive near-light travel, it must be built to endure a long history of acceleration, exposure, correction, and braking. The traveler discovers yet another unwelcome truth. Even before the speed of light becomes impossible, everything required to approach it begins to look civilizationally monstrous. Energy is where the dream finally starts to sound indecent. The kinetic energy of an object rises enormously as its speed increases, and in the relativistic regime, the numbers become brutal enough to threaten the logic of entire civilizations. It is not simply that you need a lot of power. You need so much power that ordinary language begins to protect the mind by turning the numbers abstract. A modest human-scale spacecraft pushed to a large fraction of light speed would demand energy on scales comparable to national or planetary output sustained over long intervals, depending on the propulsion method and ship mass assumed. If the vessel is not tiny but large enough to house humans, shielding, supplies, systems redundancy, and structural survivability, the requirement deepens dramatically. The journey stops looking like a transportation problem and starts looking like an act of stellar economics. This is one of the reasons the title question is more interesting than it first appears. It sounds like a thought experiment in speed. It is actually a thought experiment in the cost of nature's upper limit. Light speed is not simply very fast. It is the point at which the universe starts demanding prices so severe that speed itself becomes a moral and civilizational question. Let us now shrink the scale again because paradoxically that helps reveal the horror better. Imagine using near-light travel not to cross the galaxy, but merely to reach the nearest star, Proxima Centauri, about 4.24 light-years away. In ordinary speech, this already sounds manageable. 4 years at light speed. A single political term, a university degree, a long project. The phrase tempts the mind into comfort, but the comfort is false. From Earth's frame, even a light beam requires more than 4 years. A real ship with mass would require longer. Time spent accelerating and decelerating must be counted. Shielding must be carried. Fuel or other propulsion infrastructure must exist. The outside world ages along with the journey. Even the easy neighboring star already demands a seriousness that strips the romance from interstellar travel almost immediately. From the traveler's point of view, enough speed could make the subjective interval much shorter. This is relativity's seduction once again. But that shortness comes at the price of becoming temporally estranged from the world that sent you. A near-light voyage to even the closest stars begins teaching the same lesson that larger journeys only intensify. Rapid travel for the traveler may still mean irreversible separation from everyone else's calendar. Now widen the stage. Suppose you aimed not for the nearest star, but for the center of the Milky Way, or for some distant stellar nursery, or for the far side of the galactic disk. At near light speed, relativity would still help your subjective experience. The road ahead would contract. Your own clock would soften the burden. Yet from the galaxy's perspective, enormous spans would pass regardless. Civilizations could rise and vanish before your arrival. The map you were launched toward might already be historically obsolete when you got there. This is one of the strangest things about relativistic travel. It can make a voyage feel personal and feasible from inside while rendering it culturally catastrophic from outside. The faster you go, the more you uncouple from shared history. You do not merely traverse distance. You fall out of time with the society that named the destination in the first place. So even the apparent gift of relativity carries a wound. Near-light motion may give you the stars at the price of synchrony. You arrive younger than history expected. Everything familiar has aged away. Ultimate speed does not simply conquer distance. It dissolves belonging. Then comes the visual madness of the forward sky. At extreme relativistic speeds, aberration would compress more and more of the external universe into a narrowing cone in front of you. What was once spread around you becomes concentrated. The side sky empties, the rear sky dims and reddens, the front becomes crowded, bright, almost oppressive. This has consequences that go beyond pretty visuals. Navigation itself would change. Perception of direction would change. The cosmos would cease to feel like a surrounding environment and start to feel like a storm focused into one advancing wound of light. The intuitive sense of up, around, and behind would all be altered by the way incoming radiation is bent by your motion. It is easy to forget how psychologically violent that could be. Human beings evolved beneath a sky that surrounds them with stable geometry. Travel at extreme speed would deform that geometry. The stars would no longer reassure orientation. They would testify to velocity. The universe itself would begin to look like evidence against your own slow ancestral senses. And if the speed became even more extreme, the front cone would not merely brighten. It could become physically unbearable. Visible stars pushed into higher energies, background radiation hardened by blue shift, and collision-produced secondary radiation from forward shielding could all transform the ship's nose into a region of persistent hazard. The traveler would not simply be racing through darkness. The traveler would be manufacturing a new radiation problem by moving too fast for the ancient night to remain gentle. This is another place where the title's promise collapses beautifully. In imagination, light speed means effortless transit because light itself seems so clean. In physics, approaching that speed turns the universe into a harsher detector of your motion. The sky ceases to be scenery and becomes adversary. Ultimate velocity does not make space more forgiving. It makes the environment more exact in how it punishes your assumptions. Perhaps that is one of the deepest themes hidden in relativity. Nature's upper limit is not there to flatter ambition. It is there whether or not ambition finds it emotionally satisfying. Now consider the view from Earth. To those who remain behind, your ship never quite becomes light. It only approaches that condition asymptotically. Your onboard processes appear slowed. Your clocks tick more slowly. Your messages arrive increasingly distorted by the logic of relativity and delay. What feels like an audacious leap for you may look, from the home frame, like a long, strange fading into a different chronology. This difference between perspectives is not a side note. It is the emotional core of the thought experiment. People often imagine speed as a universally shared triumph. In relativity, triumph is frame-dependent. The traveler experiences contraction of distance and thinning of time. The observer at rest experiences long delay, altered causality of communication, and the knowledge that the fast-moving ship is not escaping the laws of the universe so much as entering them more deeply. There is something almost tragic in this. Two valid descriptions coexist, neither of them wrong, and the more extreme the journey becomes, the less they resemble one another. Speed divides not only places but narratives. The same voyage means one thing to the body inside and another to the history outside. At this point, the question of photons returns, because light itself seems to slip through all the difficulties that punish us. Light does not need fuel. Light does not complain about time. Light does not carry bones, blood memory, reproductive systems, or closed life support loops. A photon leaves a star and crosses the abyss as if distance were merely the cost of still existing. Why then should humans not envy it? The answer is severe precisely because it is simple. Light is not a tiny version of us. A photon is not a person simplified. The speed of light belongs naturally to entities with no rest mass. Human beings are not failing at being photons. They belong to another category of existence entirely. The fantasy of light speed travel is therefore built on a subtle act of self-erasure. It imagines that bodies can preserve their own identity while borrowing the privileges of something that is not built like a body at all. In that sense, the deepest impossibility is not engineering, it is ontological. The traveler wants to remain human and inherit the kinematic grace of massless radiation. The universe does not offer that combination freely. Still, one may ask whether the reward just below impossibility is enough. If you cannot travel at light speed, but you can travel near it, perhaps that is already sufficient for a transformed civilization. This is a more interesting question than the literal one because it shifts from fantasy to consequence. Near-light travel would indeed open astonishing possibilities. Nearby stars could become reachable within traveler lifetimes. Large regions of the galaxy could become psychologically closer to voyagers than they would appear from stationary civilizations. Entire kinds of exploration, colonization, and estrangement would become real. But the cost never disappears. The energy remains monstrous. The shielding remains brutal. The hazards of dust and radiation remain. The social consequence of temporal divergence remains. Every successful voyage near light speed would therefore be bought through a combination of engineering extremity and cultural sacrifice unlike anything in human history. So the ultimate speed of nature remains distant from what imagination first calls rapid travel. Rapid, in the human fantasy, means easy, direct, almost frictionless motion between points. Relativistic rapidity means entering a domain where motion itself changes the texture of time, light, danger, and belonging. The speed limit of the universe is not a high-performance highway. It is a borderland where reality becomes more exacting than the metaphor of speed was ever prepared for. There is another subtle cruelty worth mentioning. At sufficiently high speed, arrival itself becomes a problem. It is one thing to rush toward a distant star system at near-light velocity. It is another to survive the process of stopping. Deceleration demands almost as much seriousness as acceleration. If the ship cannot bleed off that immense kinetic commitment safely, then the destination is no destination at all. It is scenery glimpsed during a fatal overshoot. This problem is often hidden because imagination loves the middle of the journey more than its beginning and end. Yet beginnings and endings are where relativity becomes physically expensive. To accelerate a ship with mass to near light speed is already appalling. To then slow it back down in time to interact with a destination compounds the ordeal. The traveler who dreamed of rapid arrival discovers that rapid arrival without survivable braking is merely a luminous form of failure. This is philosophically revealing in its own right. Human beings often imagine success as pure access, reach the place, and the problem is solved. The universe once again refuses such simplification. Access without integration is not success. Speed without control is not freedom. Even at the highest reachable velocities, the old disciplines of patience and consequence return to reclaim the story. Suppose now that the traveler turns around. The classic twin paradox is often presented as a neat classroom puzzle, but emotionally it is one of the most brutal consequences of relativistic motion. You depart at near light speed. Your own time softens. You return. Much less time has passed for you than for those who stayed. The difference is not illusion. It is history made uneven by motion and acceleration. This means that rapid travel at relativistic speeds can become a machine for losing eras. The traveler wins against biological aging only by surrendering shared time with the civilization that raised them. Friends become old or dead. Institutions have changed. Languages have shifted. The world has kept its calendar, and you have kept another. To move very fast is therefore not simply to master distance. It is to accept that chronology itself may cease to be common ground between you and home. There is something almost mythic in this. Ancient stories imagined heroes who returned after strange journeys to find the homeland transformed. Relativity makes that myth physically respectable. Yet in doing so, it turns the fantasy of speed into a deeper meditation on what a journey costs when time no longer treats all participants equally. What if, despite everything, one kept pushing closer and closer to the limit? The equations grow harsher, the energy climbs, the radiation thickens, the forward universe contracts into a narrowing glare. The vessel hardens into shield, field, and sacrifice. Clocks aboard drift further from the old world. The body, the machine, and the culture supporting both all begin to pay for speed in different currencies. At some point, the original dream has unmistakably transformed. Nobody honest would still call this quick travel in the everyday sense. Quick travel is what a plane promises between cities, what imagination promises between worlds, when it has not yet met the structure of relativity. What the universe actually offers near its ultimate speed is not convenience, but transformation. The road does not become shorter in a friendly way. It becomes stranger. The traveler does not remain ordinary while moving faster. The traveler enters a domain where reality itself exacts philosophical payment. This is why the title question is ultimately so rich. It sounds like a question about haste and resolves into a question about what a human being is willing to become in order to move through a universe that did not evolve for human comfort. There is another cruelty hidden inside the fantasy, and it concerns the body long before it concerns the stars. People speak of great speeds as though speed were a single condition, a number on a display, a final state of motion one simply enters. Real travel is not like that. A body does not jump from stillness to near light velocity by narrative permission. It must be accelerated. And acceleration is not an abstract line on a graph when flesh is inside the ship. It is pressure, strain, blood displaced against vessels, bones loaded, organs forced to negotiate with motion that does not care whether life evolved for it or not. If acceleration is gentle enough to remain tolerable for long periods, the voyage lengthens before the strange rewards of relativity truly become dramatic. If acceleration is fierce enough to shorten the climb, the ship becomes a machine for testing what bodies can survive. This introduces a grim asymmetry into the dream. The traveler wants to imagine the stars rushing close, but the first real experience of such a voyage may be the pressure of being pushed into one seat for days, months, perhaps longer, depending on the mission profile. Even in a highly advanced vessel, the body would not experience speed as pure liberation. It would first experience it as being compelled by a force so persistent that comfort itself becomes technical rather than natural. This is philosophically important because it reminds us that every fantasy of transcendence begins in some medium that resists it. Human beings love final states. Physics insists on transitions. Before the sky bends, before the stars blue shift, before time begins to separate the traveler from home. There is the crude biological fact that to move faster, one must be made to move faster. The speed of light sounds elegant because photons are born in motion. Human beings would reach for it by enduring an ordeal. Then there is the question of what home becomes while you accelerate away from it. The emotional imagination of light-speed travel often dwells on the destination, but departures have their own violence. Earth would recede first into a planet, then a bright planet, then one point among others. The sun would become one star in a field. Familiar constellations would loosen. The ancient sky that guided sailors, farmers, lovers, and astronomers for millennia would begin to deform under aberration and velocity. You would not simply be going somewhere. You would be watching the oldest human backdrop unravel. Communication with home would also become stranger by degrees. Even before relativity becomes extreme, light delay begins its work. Messages to and from Earth take longer. Replies arrive out of rhythm with feeling. Conversations stop being conversations and become exchanges between different presents. As your speed grows, time dilation deepens the separation further. It would no longer be enough to say that home is far away. Home would become chronologically foreign. The people who love you remain in one calendar. You begin living in another. This is where near-light travel starts to feel less like exploration and more like a chosen exile carried out under mathematical supervision. You can still send words, you can still receive words, but the words lose the immediacy by which ordinary affection survives. The ship becomes not just a vehicle moving through space, but a machine that manufactures temporal loneliness. A fast enough traveler might leave one civilization and arrive in the future of another, even if both still use the same language to describe the same stars. The true cost of speed is not always fuel. Sometimes it is shared time itself. As the velocity rises, the external universe would cease to resemble a destination map and begin to resemble a sensory crisis. The forward sky would not simply get brighter. It would become oppressive in a way difficult to capture without sounding hallucinatory. More and more light from more and more directions would be funneled into the region ahead. Starlight would crowd. Background light would harden. Empty black between stars would lose some of its old tranquility because motion itself would make the cosmos feel concentrated. This is one reason the familiar science fiction image of graceful streaking stars is emotionally misleading. The real strangeness is subtler and more radical. The universe would become less symmetrical. You would feel that asymmetry every time you looked outside. There would be a front to reality now, a privileged direction, a wound of motion through which the cosmos poured at altered color and intensity. Behind you, the sky would cool, redden, and thin almost toward forgetfulness. Ahead, it would grow hard and crowded, as though all visible existence were being folded into a narrow promise that became more dangerous the closer you came to believing it. There is a philosophical loneliness in this too. Human beings evolved under skies that, whatever their weather, still surrounded them democratically. Up was not morally different from around. At relativistic speed, symmetry itself starts to fail at the sensory level. Motion gives the cosmos preference. The traveler no longer inhabits a world, the traveler inhabits a direction. That is a very strange way for a conscious creature to live. The cosmic microwave background deepens this strangeness into genuine dread. In ordinary life, the background radiation of the universe is unimaginably gentle, a cold relic glow left from the early cosmos, stretched into microwaves by the expansion of space. It is one of the most beautiful scientific facts we possess because it means the universe is still, in a faint sense, luminous with memory. But at sufficiently high speeds, even this ancient softness turns against the traveler. Blue shifted far enough and the background ceases to be microwave radiation in any harmless ordinary sense. It is pushed upward in energy. What was once cold history becomes a harder bath of incoming radiation concentrated from the forward direction. This is one of the moments where the title question reveals its deepest irony. Light speed sounds like the path of purity because light itself is so fundamental. Yet the closer you move toward light speed, the more even the oldest and gentlest light in the universe begins to resemble a weapon. There is something almost moral in that reversal. The universe does not keep different ledgers for beauty and danger. The same background glow that helps cosmologists understand the birth of structure can become part of the hazard for a traveler moving too fast. Memory itself turns sharp. The cosmos does not only resist our engines through distance, it resists them by altering the character of things we thought we understood. Even the afterglow of creation has conditions under which it stops being serene. Suppose, though, that the ship survives the radiation, the dust, the acceleration, the energy burden, and the optical distortion. Suppose it remains coherent and conscious. The next great question is what destination means in such a regime. A nearby star might still count as a real goal. But what about a nebula across the galaxy, or a black hole system, or the galactic center, or another galaxy altogether? At ordinary human scales, a destination is a stable place on the map. At relativistic scales, destinations become historical commitments made by one frame and inherited by another. A star you choose as a target may age little on human timescales, but the society that chose it will not. The political meaning of the voyage can mutate before arrival. Scientific priorities may change. Entire value systems can shift. The ship presses onward under equations that remain faithful while the civilizations attached to its launch and hoped for arrival have already revised themselves beyond mutual recognition. A journey near light speed does not just compress distance, it destabilizes intention. This is worth dwelling on because it reveals how naive the phrase rapid travel can be. Rapid for whom? Rapid toward what? Rapid measured against which continuity? A relativistic ship may carry a crew that experiences the crossing as difficult but finite, while the wider civilization experiences it as an epical act that dissolves the original social context almost completely. So, even if the traveler reaches the star, the arrival may feel less like fulfillment than like waking into a future that used the same mission plan for reasons no longer entirely yours. Speed, then, does not simply bring objects closer. It can tear goals loose from the histories that made them meaningful. That is one of the least appreciated and most haunting costs of extreme motion. One might try to answer all this with better propulsion. Fusion, antimatter, beam-driven sails, staged laser systems, absurdly advanced field concepts, interstellar ramjets, any architecture bold enough to make the equations seem less humiliating. It is right to imagine such things because civilizations are changed by the tools they dare to build. But it is also necessary to understand what even the most ambitious propulsion concepts are really buying. They are not buying exemption from relativity. They are buying a deeper and more expensive way of entering it. Better propulsion may get a ship to 90% of light speed, or 99, or something so extreme that the numbers begin to look fictional. Yet each success only intensifies the side effects already waiting. Time dilation, aberration, blue shift, shielding demands, dust violence, and the near impossibility of matching the traveler's chronology with anyone at rest. There is no version of advanced propulsion that turns relativity back into common sense. The better the engine, the stranger the voyage becomes. This is why the documentary version of the subject is so much more interesting than the fantasy version. The fantasy imagines a shortcut. The documentary truth is that nature has placed its greatest speed inside a web of consequences so rich that every gain opens 3 new problems. A powerful civilization may indeed approach the light barrier, but if it does, it will discover not a clean road, but a philosophical machine that changes the meaning of motion itself. There is another idea people often underestimate: simultaneity. At everyday speeds, it feels obvious that events happening now for one observer can also be discussed as happening now for another, even if the other is far away and communication is delayed. Relativity unsettles this much more deeply than most casual treatments admit. The notion of what counts as simultaneous depends on the observer's motion. This is not just a technical subtlety. It means the traveler at relativistic speed and the stationary observer do not share one universal present sliced cleanly across space. That matters because the imagination of travel is built on hidden assumptions about now. You think of yourself departing Earth now, crossing space now, arriving elsewhere later. But the deeper structure of space-time refuses to grant one single now that all participants keep in common. Different frames carve the fabric differently. The world line of the traveler and the world line of the home civilization already carry different temporal architectures before any emotional interpretation is added. This makes the experience of near-light travel feel almost metaphysically alien. The separation between traveler and home is not only practical or emotional, it is built into the structure of time itself. The voyage does not just take you farther away, it moves you into a different ordering of events. One begins to see why the speed of light is not the key to ordinary rapid travel. It is the threshold at which the common human illusion of one shared temporal stage begins to fail. And if all this were not enough, there remains the question of perception inside the ship itself. Human beings do not merely travel. They interpret what travel means through senses evolved in low-speed environments. Vision, balance, expectation, and emotional orientation all assume a world in which space behaves stably enough that movement does not rewrite reality's appearance too violently. Near light speed, that assumption collapses. What would it feel like to know that the sky outside is not lying and yet cannot be trusted intuitively? That color no longer means temperature in the old way. That brightness is partly velocity. That the stars ahead are compressed, not because the universe is actually bunching up physically like a curtain, but because the logic of incoming light has altered. That the rear cosmos is fading not because it is gone, but because you have moved into a relation with it so extreme that even ancient starlight now arrives diminished. This could produce a strange psychological burden. The traveler may remain intellectually informed, surrounded by instruments, equations, and expert interpretations, and still feel that the raw universe has become uncanny, not magical, not hallucinatory, simply too transformed by motion to remain emotionally natural. The ship becomes a place where human cognition must be repeatedly educated against its own senses. In that sense, Traveling near light speed would not only challenge engineering, it would challenge sanity's old partnership with ordinary perception. Now return to the twin paradox, but refuse to leave it at the classroom level. Imagine the actual human consequence. You depart, your ship works, you survive. Years pass for others, perhaps many years, while only a fraction pass for you. You come back if coming back remains possible. The old home has continued, aged, altered, mourned, celebrated, forgotten things you still hold freshly in mind. Entire generations may now stand where your peers once stood. This is not just an interesting quirk of relativity. It is a wound to the social meaning of travel. Exploration has always carried the pain of separation, but relativistic exploration weaponizes that pain with mathematics. It allows you to go farther by making your own life less synchronous with the ones you care about. The victory over biological aging during the voyage is bought with a form of civilizational bereavement. You preserve your own years by surrendering common years. That is why the dream of fast travel is less innocent than it first appears. On Earth, speed usually means more life compressed into less waiting. In relativity, speed may mean preserving your own subjective continuity while abandoning shared continuity with the world. The journey becomes a kind of selective mercy granted to one timeline at the expense of another. By now, the answer to the original question has become almost brutally clear. You cannot travel at the speed of light if you remain a massive human being. But even approaching it does not deliver what the phrase rapid travel promised. Yes, time slows for you. Yes, distances contract in your frame. Yes, the stars can become, in principle, more reachable to your own body than the outside world's calendar would suggest. But every one of those gifts comes tied to consequences that grow stranger the closer you come to the limit. The universe ahead becomes optically and radiatively violent. The medium between stars turns dangerous. The energy cost swells toward monstrosity. Acceleration and deceleration refuse to disappear into cinematic convenience. Simultaneity fractures. Communication thins into delay and estrangement. Arrival itself becomes a negotiation with history rather than a simple triumph over miles. The ship does not glide into freedom. It enters a domain where speed has ceased to mean what slow creatures once hoped it meant. That is why the speed of light remains so far from the human idea of fast travel. It is not the final expression of convenience. It is the upper edge of nature's permission. And that edge is guarded by consequences so profound that the old fantasy burns away long before the last decimal place is reached. In the end, what if you traveled at the speed of light? The strict answer is still no. Not if you remain a massive traveler. Not if you remain embodied in the way human beings currently understand embodiment. But the more interesting answer lies in the approach. As you move closer and closer to that ultimate limit, the universe begins to reveal what the phrase really concealed. Time is no longer universal in the old intuitive sense. Distance is no longer stable, light is no longer gentle, motion is no longer just motion. Everything that once sounded like a shortcut becomes a lesson in structure. The final irony is as beautiful as it is merciless. The speed of light seems like the perfect symbol of effortless travel because light itself crosses the cosmos with incomparable grace. But for beings like us, made of matter, duration, memory, and vulnerable bodies, that grace is not ours to inherit cleanly. The closer we come to the universe's ultimate speed, the more completely we discover how unlike light we truly are. So the real answer is not that the speed of light is too fast for us. It is that the speed of light belongs to a deeper order of reality than the one our ordinary fantasy of travel was built to understand. We imagined a shortcut. The universe offered a threshold. We imagined a road. The universe offered a transformation. And perhaps that is the most fascinating lesson of all. Nature placed its supreme speed, not where desire could simply enjoy it, but where desire would finally be forced to learn humility.